Welcome to Two Projects. In this video, we are going to explain the project application of the convolutional neural networks and supervised deep learning methods for osteosarcoma bone cancer classification. So, before diving into the execution, let me give you an overview of the project. So, the project's main aim is to create a system that can recognize a specific type of bone cancer called osteosarcoma. So, this type of cancer typically affects the long bones in our body, such as those found in our arms and legs. So, the system will be built using advanced deep learning techniques, particularly convolutional neural networks, which are very good at understanding images. But why is this important? Early detection of osteosarcoma is crucial for effective treatment. The sooner we can identify it, the better chance we have of treating it successfully and improving the patient's health. So now we will see how does the system work. So it is going to look at images of bone tissues and categorize them into different groups: non-tumor, viable tumor and non-viable tumor. So we will be training the models with non-tumor images, viable tumor images and non-viable tumor images. So let us understand what are these. So non-tumor images are pictures of healthy bone tissues with no signs of cancer. Viable tumor images show bone tissue with active cancer cells indicating the presence of a growing tumor that needs attention. Coming to non-viable tumor images, these images depict bone tissue with tumor cells that are no longer active, either because they have died or become inactive. Understanding this distinction is essential for planning the right treatment strategy. So, to train the system to do this classification, we have to feed a lot of labeled images. So, each image will be labeled with its corresponding category. This process is called supervised learning. So, with enough examples or training samples, the system learns to categorize the patterns and features associated with each type of image. So, traditional methods of detecting and classifying osteosarcoma, like histopathological examination, usually involve manual interpretation by experts. This process is time consuming and may vary between different observers, leading to inconsistencies in diagnosis. That is why we are using deep learning in this project. Instead of relying solely on human interpretation, these methods use advanced algorithms to automatically analyze medical images. One of the key benefits is that they can learn directly from the images themselves. Now we will see the workflow. So in this project, we have used a dataset containing bone cancer histopathological images. So before these images are fed into the deep learning models, they undergo several pre-processing steps to prepare them for analysis. So these steps include rescaling, that is normalizing the pixel values, shear transformation, that is changing the orientation of the images, zooming in and out, flipping the images horizontally, and reshaping them to a standardized format. So we'll do these image data generator techniques so that the model will learn the images from different angles and generalize well in all the situations. After that, we will utilize pre-trained deep learning models like ResNet 101, VGG16, etc. So these models have been previously trained on large datasets for general image recognition tasks. Instead of starting from scratch, we will take advantage of the knowledge these models have already gained about recognizing various features in images. So this is called as transfer learning. Ultimately, the goal of the project is to develop a tool that can support doctors and other beneficiaries in identifying osteosarcoma early and accurately, which can lead to better treatment decisions and outcomes for patients. So, this is what we are doing in this project. Now we'll see the software and hardware requirements. So hardware requirements needed to execute this project are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application needed is Anaconda, primary language used is Python, front-end framework needed is Flask, backend framework required is Jupyter Notebook, database needed is SQLite 3, and front-end technologies required are HTML, CSS, JavaScript, and Bootstrap 4. Now we look at the algorithms built. So in the base paper, author has proposed these models ResNet 101, VGG16, VGG19, and DenseNet 201. For improved performance, we are proposing exception model in this project. We will be building all these models, the models proposed by the author and the model which we are proposing, and we'll compare their performance with different performance metrics like accuracy, precision, recall, F1 score, and we'll select the best performing model among them for osteosarcoma bone cancer classification. Now we'll understand about the algorithm which we have proposed, that is exception. So exception is a special kind of deep learning technique. It is known for being good at understanding images. So it does this by breaking down the process of looking at images into two main steps. First, it looks at different parts of the image separately. This is called depth-wise convolution. Then it combines these parts to understand how they relate to each other. This is called point-wise convolution. This helps exception to understand images better and pick up on important details. One of its strengths is that it is really efficient at doing this, which is important when you're dealing with lots of images like in medical analysis. And it is great at figuring out what features in the images are important for making classifications. Another important thing about exception is that it can learn from other datasets before being used for a specific task. That is transfer learning. So this makes it super adaptable and useful for projects like detecting and classifying osteosarcoma from medical images. So that is about exception. And after comparing all these models, we have observed that exception model has outperformed all other models in all the performance metrics. So we have deployed exception model into the Flask framework. Now we'll see the execution. We will be executing the project using Flask web application. Before that, first we need to open the code folder which contains the project source code files. So this is the code folder and these are the contents I have in the code folder. I'm opening dataset folder in which I have required bone cancer histopathological images. So I have three classes: non-tumor, non-viable tumor, and viable tumor. So in these folders, I have respective tumor images. These are non-tumor images I have. These are non-viable tumor images. And these are viable tumor images I have. So before training the deep learning models, before feeding these images into the deep learning models, we will perform pre-processing steps on these images. So as I mentioned earlier, we will use image data generator techniques like shared transformation, rescaling, horizontal flipping, etc. After that, we will split the dataset, these images from all these three folders into train and validation sets in the ratio of 80:20. So after splitting, these train and validation sets are stored in this output folder. Now, 80% of the images of non-tumor, non-viable tumor, and viable tumor are now into train set. Similarly, 20% of the images of non-tumor, non-viable tumor, and viable tumor are now in validation set. So train set is for training the models. Now we will train the deep learning models using this dataset, the dataset which is in the train folder. And we will test the models, we'll evaluate the models using validation set. So this is about the dataset. This is sample folder in which I have images again, the bone cancer histopathological images, on which we'll make the classifications. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained models. This is notebook Jupyter source file which contains combination of code, graphs, and outputs all in one place. So Jupyter Notebook allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information, that is sign up details. So now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost, and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. And here we can see a sign up link, click on it. So if we are new users, we have to register ourselves first, fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I'm already a member, I'm clicking on this link. Here we have to give our credentials, username and password. I'm giving mine and click on login button. So it has redirected us to the classification page. So now we have to upload any bone tissues histopathological image here, and the application will classify the type of tumor from the image. Click on choose file button. So from sample images folder where I have test cases, we'll select any non-tumor image first. I'm selecting this one and click on open. The image has been loaded. Now click on upload button. So this is the uploaded image, the histopathological image. And here we can see the classification, that is non-tumorous. So the application has correctly classified this bone tissue as non-tumorous. That means the bone tissue is healthy with no signs of cancer. Click on classification link. We'll try again giving another image. Click on choose file button. This time we'll upload any non-viable tumorous image. I'm selecting this one and click on open. The image has been loaded. Now click on upload button. So this is the uploaded bone tissue image, and here we can see the classification, that is non-viable tumor. So the application has correctly classified it as non-viable tumorous. That means there is a tumor detected in the bone tissue, but that is no longer active. We'll try again. Click on classification link. Click on choose file button. We'll try with viable tumorous images. I'm selecting this image and click on open. The image has been loaded. Now click on upload button. So this is the uploaded image And here we can see the classification, that is viable tumorous. The application has correctly classified it as viable tumorous. That means there is an active cancer cell in this bone tissue, indicating the presence of a growing tumor that needs attention. So he has to see a doctor soon. Click on classification button. We'll try giving some more test cases. Click on choose file button. I'm uploading this one. This is the image I have uploaded. And here we can see the classification, that is viable tumorous. Click on choose file. Select the image. I'm uploading non-tumorous image. Click on upload. This is the uploaded image. And here we can see the prediction, the classification, that is non-tumorous. Click on classification. Click on choose file. Select the image. Click on open and click on upload. And here we can see the classification, that is non-tumorous again. Similarly, we can upload any histopathological bone tissue image and the application will classify the type of tumor from the image. Click on choose file, select the image, click on open and click on upload button. This is the uploaded image and here we can see the classification, that is non-viable tumor. This time we'll upload this one. We can see the correct classification, that is viable tumor. So in this way, we can upload any image from these test cases and can get the classifications. The classification here is non-tumorous. Now we'll see the visualizations. Here we can see a graph link, click on it. So here we can view all the plots. So this is loss and accuracy curve of exception. I'm zooming it. So in this graph on x-axis, I have epochs and on y-axis, I have loss. So here, blue color line represents training loss and orange color line represents validation loss. So we can see for every increasing epoch, loss is also decreasing. And here, this is accuracy graph. In this graph on x-axis, I have epochs and on y-axis, I have accuracy. Here, blue line represents training accuracy and validation. The orange line represents validation accuracy. So for every increasing epoch, accuracy is increasing. That means the exception model is doing well. And this is accuracy scores comparison graph. So it is a horizontal bar graph. In this graph on x-axis, I have accuracy scores and on y-axis, I have algorithm names. So accuracy is a measure of how well a model correctly predicts outcomes. It represents the proportion of correctly classified instances among all instances evaluated. Similarly, this is precision scores comparison graph. So precision is a measure of the correctness of positive predictions made by a classifier. This is recall scores comparison graph. Recall is a measure of the classifier's ability to correctly identify all relevant instances from a dataset. And coming to F1 score combines precision and recall into a single value. It provides a balance between precision and recall, taking into account both false positives and false negatives. And these are other graphs. This is ROC graph and this is V-score graph. So in all these graphs, we can see exception model is doing well. Now click on sign out. So the project successfully developed a system using the exception model for detecting osteosarcoma. So we have deployed via Flask. It offers a user-friendly interface for uploading and testing medical images. And with high accuracy and automated analysis, this system aids in early detection and treatment planning, benefiting patient outcomes in oncology.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.